Functional inverse. Inverse is like reversing something. Okay, let's get started. So what's an inverse? An inverse operation or function is an operation or function that reverses another operation or function. Alright, the key word here is reverse. Right? So it's an operation or function. Right? Alright, so examples. The additive inverse of 3 is negative 3. To reverse adding 3, you add negative 3 or subtract 3. Right? So addition and subtraction are reverses of each other. They inverse each other. The multiplicative inverse of 4 is 1/4. To reverse multiplying by 4, you multiply by its reciprocal, 1/4, or you divide by 4. Right? So the idea is an inverse is you undo something, you reverse something. A functional inverse looks like this. Well, this is one of the here, one of the way it looks. A function is an inverse of another function if the roles of y and x are reversed. So here, x, 2, 3, 4, 5. And then come over here, the y's are 2, 3, 4, 5. Y's over here are 5, 7, 9, and 11. And then the x's over here are 5, 7, 9, 11. So it's the x become the y's and the y's become the x. Those are functional inverse. That's a functional inverse. All right. That means if we're given a function, we can find its inverse. So first we take, so this is the original function, rewrite it, switch in x and y. Okay, now solve the new equation for y. So I'm going to move the y to the left by using the symmetric property of equality, and then divide by 2. That's the inverse function, which kind of makes sense, right? If the original function is 2 times x, then the inverse is x divided by 2. Okay. Another example. Now this is using functional notation, but yeah, it does get in the way. We're going to rewrite it with normal variables. And then swap them. Right? So this is the original function, and we get to this. If you skip this step, that's okay. Alright. So we swap the x and y's, and then you solve for y. Alright, move everything to the left, yada yada yada. So you have this new function. And we're going to rewrite this using functional notation. So this is the functional notation for the original function, f of x equals 3x plus 4. So what will we write when we're using functional notation, but we can't write f anymore, right? We don't write f. I guess we could write g. But this is it. F with a -1 on there lets us know it's a functional inverse. Right? So the new notation looks like this. So this is it. If f looks like an exponent of -1, but this means functional inverse, right? And we read it f inverse. It's not an exponent. This -1 is not an exponent. Yeah, that's one of the confusing things about math. Alright, this means that this function is the inverse of function f of x. So f inverse x is the inverse of function f. So what does it mean? So the inverse of g would be written g inverse. So remember, f is not a specific function. F is a generic function. F is just a name of a function. So it could have a bunch of different names. G is one. In fact, sine, if you remember from geometry, the inverse of sine x is written sine -1x or sine inverse x. Okay, so this is on your calculator, right? There's sine, cosine, tangent, and then there's the inverse versions right above them. All right. So now we're going to verify the inverse. So this is the function, and this is supposed to be the inverse. Maybe it's not. Alright, so if we plug in 2, we get 3 times 2 is 6. 6 plus 4 is 10. Okay, so f of 2 equals 10. And here, what we're going to do is plug 10 in, and we get 1/3, 10 minus 4. Right? Or we plug the 10 in. 10 minus 4 is 6, and f inverse 10 is 2. So this 2 was the original input over here, and this 10 that came out of the original function is inputted into the inverse function. Okay, the roles are reversed. Okay, now this was just an example of how a function and its inverse behave. Okay, this is not how we're going to actually verify. So this is just an example of how that works. All right, now this is regular table, right? Determine whether or not the functions are inverses of each other. So this is a typical problem. When we're given two tables, we just check it out. So here, 2, 3, 4, 5, 2, 3, 4, 5, -7, -3, 4, 13, -7, -3, 4, 13. They have to be identical, but swapped. So f and g are inverse functions of each other, right? Because the x values and the y values, no matter even if I call it f of x or g of x, the second column are the y value. Here's another one. So here's 2, 7, 14, 13, and that's not it. Even though 2, 3, 4, 5 is over here, 2, 3, 4, 5, but the x's and the h of x are different. So this is not, they are not inverses of each other. Okay, just because one column is the same doesn't make it inverse of each other. The 2 to 2 matches up, but the 7 doesn't go with the 6. So this is wrong. That doesn't work. So. All right. What if we're given equations or algebraic expressions to determine whether they're functional inverses of each other? All right. So this is the first method. Actually find the inverse. So take that equation and find the inverse. All right. So here, 1/3 x plus 2. Switch to variables. Solve for y. So here I'm subtracting 2 from both sides, and then I multiply by 3, right? So that's that. And if we distribute, you get 3x minus 6. Well, that's not the same as 3x minus 2. So they are not the same. They are not the inverse. Okay, that's method 1, finding the inverse. All right, sometimes this is actually kind of hard, right? Trying to get from one to the other. All right, method 2. Substitute one inside the other. This is the suggested method. Well, I don't care which method you use. Okay, substitute one inside the other. If they are inverses of each other, the result is x. That means if you put like g into f and you get x, that means they're inverses. All right, so that's what it means. So f of g of x. You're substituting this whole expression into x. So wherever the x was, you put g of x. So that's here. It's 1/3 x plus 2. So it's now 1/3 g of x plus 2. But what's g of x? G of x is this whole thing. So that means I got to replace that g of x with 3x minus 2. And here, 1/3. I'm distributing the 1/3. So 1/3 times 3x is x. 1/3 times minus 2 is negative 2/3. Okay. These two, the negative 2/3 and 2, don't cancel each other out. So it's not x, so that means these are not inverse of each other. Alright, look at one. Or it does work out. So this looks kind of creepy. So I'm still using method 2. So I'm going to substitute g of x into f of x. Alright. So we're going to replace the x. So the x appears in one place over here, and we're going to put this whole expression in that spot. So this plus 2 is this plus 2, right? And minus 3 is minus 3 here. The one on top is the one on top here. But this x has been replaced by that whole function. This is the whole function of g of x. It's replacing just that one variable x. So it's 1 over x plus 3 minus 2. Now let's work this out. The negative 2 and positive 2 cancel each other out. So it leaves me 1 over x plus 3. But remember, when you have something that looks like this, you take the reciprocal of the denominator. We're taking the reciprocal of the denominator. So that's x plus 3. And now look, the 3 and minus 3 cancel. So f of g of x ended up being x. Now technically we're supposed to do it the other way too, but I'm lazy. In our functions that I give you won't be so complicated that you have to do it twice. So we're going to just do it once. All right. So f and g are inverses because this worked, because we resulted in this. Right. So what is expected from you for this section? Find the inverse of a function. So that's what we did at the beginning, right? Where we switched the variables x and y and then solve for y. You're to verify whether two functions are inverses of each other. You just saw that, where you substitute one into the other and you want the result to be x. But you have to do it if you're given functions as tables, right? That's easy. You just look at the left column and the right column and the right column and the left column. If they're the same, then you got the inverses. Algebraic expressions, that's what we just finished. That was the last slide we did, right? Where you take one and you shove it in the other and it produces x. It's a inverse. If it doesn't produce x, then it's not an inverse.